Hello. Yeah. Can you hear me right now? Is my sound, video, audio, everything clear right now? I guess it should fine. Yeah. Now it's clear. That's great. That's great. Okay. So we will be starting within few minutes. Let's everyone join and we'll be starting our class. All right. Let me text also the code. Yeah. Hi, Ovis. How are you? My day was super fine. How about you? Okay, so I'm really glad to see you all again in the class and amazing. So let's start our today's session without wasting any further much time. Uh, all right, let me share my screen. Okay, so I hope my screen is visible to you. Hello, hello everyone. Amazing. So let's start our today's session with full of energy. I know you might be coming after your classes, after your long day. You may be super tired, maybe super, uh, low energetic, but definitely today's session gonna be full of fun. All right. Lunch, tea. Okay. Yeah. Hi. Hi, Shankit. So welcome to you all in our today's session. And okay, so tomorrow you are having your exam, right? Best of luck for your exam. Don't worry, exam gonna be fine. Exam is just like, you know, every time you got the exams, and uh, it's just a stress for a few days. Once the exams are finished, you are tension free, right? All right. Mhm. Yeah, I got you, got you. Don't worry, our class will be not much longer for today. It will be around 1 hour, not more than that. Okay. Yeah, what's up? I'm fine. Okay, so give me a thumbs up that you guys are ready and we can start our session. Show me a thumbs up in the chat box. Everyone, quick, quick, quick. Come on. Yeah. Let me see the thumbs up, guys. Yeah, that's it. That should be the spirit. That should be the spirit, my boys and girls. Okay, guys, so today, so far we have already covered the 50% roadmap of our workshop. So you guys are right now having hands-on experience over Arduino, how to use Arduino, how to interface LED, how to build projects, right? So you guys are knowing all the logic, how the logic works, how to, program it using picto blocks, right? And now, as our interval or the half of our workshop has been completed, right now we will be stepping into the actual programming part. All right. So, right now, we're going to learn how to directly write codes in Arduino IDE, right? And which language we will be using? The coding language will be C++. All right. So, Many of you are familiar with the language C, right? C language, or you have heard about C language, right? So C++ is basically, you know, same as C language, but it's more structured C language. All right. So they both are around same things, right? But C++ is much more advanced than C language. So if you are knowing C language, it's not a big deal to you understand C++, all right? But no need to worry, even if you are new to the coding languages, you don't understand any type of coding languages, no, not an issue. I'm here for it, right? So I will be connecting all the dots from the beginning of the workshop. Great. All right. So all the dots gonna be connected. So मजा आ जाएगा आज के सेशन में. All right. So guys, let's go and let's move on. Let's see what comes the next. Okay. All right. So let's recap what we have learned in our previous session. So in our previous session, we have learned about analog control, how to interface with sensors like push button, right? How to use the push button. What are the analog pins? What are the input pins? What are the output PWM pins, which can take the analog signal, okay, by giving the first digital pulses, right? And then we talk about like how to interface LEDs with a push button such that you can change the states. Then we have did our project, which is about building your own signal system and all those things, right? Then we talk about our, uh, other things, right? But today we will be focusing on C++ codes and how to write it and how to handle complex, problems or sensors using our, coding, right? And let me give you a hint how the session going to be very interesting. For example, uh, in our last session, we have interfaced push button, and I guess each and one of you have felt like interfacing this push button is quite a bit, tricky, right? So interfacing this, push button is quite tricky. Why is that? Because we need to interface, a resistance. Then we have to connect the power supply, ground pin, and then the EWM pin, all those things, right? Today, I'm going to show you that when you write the codes using C++, it became much easier to interface a push button where you didn't require a resistance also. Okay. So without the use of resistance, we're gonna see how we can interface a push button. All right. So are you guys, super ready for our today's session? Let's move on. All right. So let's bridge the gap between the blocks and to the sequence, right? So you guys are familiar with pictoblocks, right? You all are familiar with the pictoblocks, right? So if I want to show you, all right. So this is our pictoblocks, right? This is our pictoblocks where we can drag and drop all the blocks, and then we can write the codes, isn't it? Right? So we can create any variable, then we can set the variable, we can read the variables, right? And then we can check the conditions using the if else statements, right? And it's very easy, right? You can just grab and pull all this block together, build it, and just beside it, you can see this code. Right? And what is this code is? So this is known as our C++ code, right? So this code is C++ code. And if we want to, write this code directly without, building these blocks, what we can do? So For that reason, you have to learn the C++ programming. And I'm gonna teach you C++ programming, and you will be like, whoa, it's not that hard what we used to think uh, previously, right? So it was like, okay, whenever you don't know anything, you will be like, it's so hard to learn. It's not that easy. I will be not able to understand it, but it's super easy, right? And as you are having the foundation with the pictoblocks, you have the foundation with the logics, how to use those blocks. It's gonna be super easy for you to understand the coding part. All right. So let's move on to our PPT again, and you know, let's see. So for understanding the C++, we first need to understand the syntax. So what we were doing in the pictoblocks were we were using visual logics, right? So we were using visual logics, and then we are converting those visual logics into text syntax, right? So as you can see, what we were doing was we were just, uh, as you can see here, what we were doing, we were just converting this visual, form. This is the visual form, this blocks, right? And this visual form we are converting into text, right? Our pictoblocks is converting this visuals into text. And then we are copying this text, and then we can run it on the workpiece, right? So that's what's happening. But now what we're gonna do is we're gonna directly write that text sentence. Okay? We'll be directly working with the text, right? And we'll be working on the C++ IDE or workpiece, right? So what is IDE? So IDE is the you know godfather of all the software where we can directly interface our Arduino with. Okay, so Arduino IDE is Arduino's official, software through which we can upload codes into this Arduino board. Okay, so if we want to, add anything into the Arduino board, if we want to run the codes, then we use the Arduino IDE, right? So let me first show you what the Arduino IDE looks like. Then we will be proceeding. All right. Amazing. Okay. Yeah. So let me just show you. Okay. Now I have to just search IDE. So I have to first install it. This is known as Arduino IDE. You can just search it in your Google Chrome, and you can download the Arduino IDE software. And once you install it, you can just turn it on. So if I click on it, you can see this is what the Arduino IDE looks like already. All right. So this is how the Arduino IE looks like, where you will be able to find this file sketch underscore tech 4 ino. You can rename it as you want. And as you can see, this is the part where we can code, right? So in detail, we will be learning how to code, how to upload the codes, and what are the other things, how to see the outputs, all those things. No need to worry about that. But before we move on, let's see our PPT again. All right, amazing. Okay, so if let's talk about the foundation of C++ programming and its structure. All right. So whenever you enter the terminal or whenever you enter the IDE to code the C++ or to code the Arduino code, write code for Arduino, Then what you need to do is you have to just see the two things are there. That is one void setup, okay, and another is void loop. All right. So if I want to show you, then you can see, yeah. So you can see. So here you can see. Okay, I think it's not visible. Yeah, I think you can see, right? So here you can see there is two thing which is in default, right? So this two thing you will be finding default whenever you enter the Arduino IDE, and those things are this two function: void setup and void loop, right? Void setup and void loop. Now, what are these things, right? So these things are basically the setup which runs the code once, only once. So whenever you just yeah, just click the run button, it runs the code inside the setup block or void setup block just for once, exactly for once, right? So it's used to for initialization. So it's initialize the code. For example, I want to set up the code for pin number 3 for the LED pin, right? So if I want to set up something, I use this void setup. Got it? Got it? And next part is the loop. Okay. So the loop or the void loop function, these all are functions. So these functions are used for the repetitive work, or you can say it's act like a forever loop. If you connect it with the pictoblocks, so in pictoblocks we used to grab one palette known as forever block, right? So that forever block is basically this function which is void loop, right? So inside this void loop, whatever I hope I'm audible now, right? All right. Amazing. So, what I was explaining was that in we will be what we were discussing was regarding the rules of C++. plus plus. Okay, so what are the rules in C++? plus plus? So before you start playing a game, you must know the rules of that game, right? So before you start playing kabaddi, you must know what are the rules of kabaddi, right? Or any other game. It can be badminton, it can be judo, or anything. To first know, you need to know the rules, right? So similarly, before learning any programming language, you must know the rules of that programming language. So if it's about C++, plus plus, so there are three major rules you must always know. Okay. So the first rule is about the semicolons, right? So what are the semicolons? Semicolons is basically this symbols, right? This symbols. And this symbol, semicolon, you should always use after each single instruction line or after each line of code, you must use the semicolon, right? For example, here you can see in this code, what's happening here? This is a function void setup, right? And where we set our, pins, right? Where we set the LED pin, we set the, push button pins and all those things, right? So whichever things we need to run at the beginning, for once we used the void setup, right? So inside this function, you can see that every line ends with a semicolon, right? Every line ends with a semicolon. And you must always make sure, except the functions which you're going to use, like if else, and setup, void loop, you must always end up every single line of code with a semicolon. You should end every line of code with a semicolon in this C++, right? So this thing you have to always make sure, right? You can see in the void loop, here I am having digital right, and after the ending, it's also having this semicolon, 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 semicolon. Got it? I hope it's clear, right? Now let's talk about the next, our rule, that is brackets. So basically, two types of brackets are used in the programming language C++, plus plus, right? And the bracket are one curly bracket or normal bracket. One is normal bracket, one is curly bracket, right? And depending on where we are using it, the place of use will be different. For example, in our previous example, if we see, so here you can see for defining this function void setup, okay, this is the void setup function. These are the two brackets we have used. One is normal bracket. So while defining the function, we have to use this normal bracket, like void setup, it's a function. And after this, we have to use the curly bracket. And we have to write our all the instructions or the code inside that curly bracket, right? See, this is curly bracket open, and inside we have written this code, right? And then we close the curly bracket. Similarly, here in this void loop, we have used this bracket to, define it is a, function. And then we use this curly bracket and open. And inside this curly bracket, we have written our code, right? And you have to always make sure that once you start a bracket, you must always close it. Otherwise, it will show you a error. All right. So these are the basic things. I know you are understanding some of the part. You are not understanding few of the parts. No need to worry about that. We're gonna do it hands on. Then it will be super clear, right? So just stay with me. Now, the third rule is about comments, right? So what are basically comments? So in the YouTube section, there is a section name is comment section. I know you guys never comment in this in my videos, but yeah, there is a comment section where you can comment, where you can show your love, right? How much you are, liking the stations. So that comment section is basically what whenever you go to any video, any new video of some YouTubers, you just go to their comment section and you try to find out what are the responses, what are the comments of people after watching this video, and after getting the understanding what are the comments of people. Is it positive comments, is it negative comment? For example, if a video's comment section says very beautiful video, amazing video, a lot of things to learn, and so you feel more confident and you feel, yeah, something is good in this video, and you start watching it, right? So it's basically helps the audience to get a better understanding about the video, right? Whether the video is good or not, right? So similarly, in programming, we use comments and to make the code much easier to understand. Okay, it's much easier to read for a programmer, right? So if you are building a project and after 2 months you again just going through all the codes which you have did 2 months earlier, and you are not understanding what's written in the code. So you just write some comments just beside the codes to make you understand how the code is working, right? So here you can see in this code block, we are having this function, right? These are the instructions, and this is known as the comments, right? And every comments is, it must start with this two symbol, right? So whenever you start any of the coding line using this symbol, it becomes a comment, and your machine will ignore this comment, right? So it will be not considered as a coding part. So you can write anything in this line. Okay. So whenever you start a line with this, you can write anything in this particular line, not in the next line. You can write anything you want, and it will be ignored, completely ignored by the compiler whenever you will be running this code, right? And another important thing is it's about how these codes are compiled, right? So you will write some codes, but you should also know how the computer is understanding this code and running this code. All right. So there is something called line by line execution. Right. So there is something called line by line execution, which happens in the interpreters, right? Python ideally and Arduino IDE, right? So here what happens if you write this code, right? So this is the code which you have written, right? And how this code is, understood by the computer is it's a line by line execution. So what will happen? It will first, execute this line. Okay. So once it's execute this line, the computer will understand this is a function, right? So what it will do? It will go to the next line and it will run this line, right? It will run this line. And after running this line successful, okay, then it will go to this line and then it will run this line. And if somehow this code is wrong, this line of code is wrong for say, for example, if I haven't given this semicolon, so this entire line will be considered as wrong. So if this line is wrong, then what will happen? Then my interpreter or the IDE will show me that it's an error, right? I have done some mistake. So it does basically, it goes line by line executing everything, and it's checked whether the codes are right or wrong. And if it's wrong, it will show you that where it was wrong. Got it? Got it? Right. So that's how the interpreter works. And in a compiler, it's runs all the code together. Even if finds something error, it still goes to all the lines and checks, and it will show you how many errors are there in your code. Right. So those are the different things. We're not going to talk deep into it, but basically the thing is how it works. We want to show. So it goes to this line, and then it finds the function is closed. Then it goes to next function or the next line. Then again it goes to this line. But here you can see this is a void setup means it will run for once. So this function will run for once. But the moment it will jump to this function, it will find this particular function which is called loop, right? So now this loop will do something because of which our computer will run this particular block again and again and again, right? How it gonna happen? So after entering into this loop, it will first run this line of code, then this line of code, right? And after completing this, it will say the block is complete. Then again, it will go back to this line, and then again it will start executing this thing, this line. Again, it will go to this part. Again, it will run this thing. So it will be running continuously, right? So that's how the execution happens in a C programming, all right, or in Arduino IDE. Now we have talked about the rules, right? Now let's talk about the variables and data type in C++. All right, amazing, amazing guys. So now let's talk about variables and data types. What are these things? So you are already familiar with the variables, the name variable, right? I have told you in our previous classes that a variable means something which value can be varied, right? So something whose value can be varied is known as variable, right? And what is the meaning of constant? Constant means something whose value can't be changed, whose value is unchanged, right? Whose value will stay unchanged. That's called constant. And variable means whose value can be changed. That is a variable, right? And what is the meaning of data type then? So data type means the types of data. Okay. So the types of data means data type. What I mean is, uh, tell me if you want to define some data, how you can define it using some quantity, right? Yes, yes, types of data that we are entering. Yes. So that type can be, what can be the types of the data, right? So if we want to know what can be the data types, it can be integer, right? Where we will be having one, two, three, minus one, right? So this all will be our integers, right? And if we talk about floating points number or float, right? So here we will be having all the decimal numbers, right? Including the integer. Okay. So 1.1, 1.3, 14.6, right? Or even 1, 2, 3, all comes under the floating point numbers, right? So that's what we call as floating point numbers or integer, right? Now, we will be not going deeper into it. What are the data types? What are the different data types? We just will be learning what are the data types we require in order to work with Arduino, right? So so data types which we need to know about are integer and float, right? So these are the two important data type which we will be using, continuously every time whenever we will be writing codes in our Arduino, right? Got it? So a variable is a container that holds a value, as we have discussed, right? So this container can holds a value, right? The pin number of the LED, pin number of the sensor, or a push button. So everything we can put inside that container is known as our variable, right? And as you can see, this block of code, this is the code where we define the variables. So whenever we are working with C++ coding, we have to make sure we first define the variables, the value of the variable. Right? So in our picto blocks, what we were doing, we were just, having all the pre-made blocks. We are just grabbing and putting them together, right? But here we have to define the blocks or define the variables first, right? If you have did the previous activity, you are well familiar with the variables, how to create variables, how to work with the variables, right? So similarly, in the coding also, we have to first define the variables, the pin numbers. So for that reason, we will be using the variables, right? So now you can see that we have taken the variable LED pin. You can write anything. You can write LED. You can write LEDP, right? You can write LED LP, right? So this code means set. This code means I have taken the pin number 13 as my LED pin. Okay. Or I'm setting the value of this LED pin or the variable LED pin as 13. Okay. Why? Because I want my Arduino to be pin number, if I want to interface my LED, I want to interface it into the like digital pin 13, right? So what I will do, I will create one variable, right? As we know, we have seen, right? To create a variable, we must to have to give it a name, right? And then we have to set it which pin we are setting our variable in. Okay. Yes. Amazing. So if I'm having the LED pin, so what I will do first, I will first ensure that my this variable, right? So whenever you are creating one variable in C language, you have to define its data type. So this is my LED pin, and as my number is a integer, so what I will do, I will define it as an integer. So it is an integer and it is a LED pin variable, right? Which is equals to 30, and it's end up with a semicolon, right? Now, you tell me, if I'm interfacing a LED to the digital pin 13, do I require to change this variable? Tell me. Do I require to change this variable ever in the code? Of course, no, right? I don't need to change the variable, right? So if I don't need to change the variable, so why don't I make it a constant, right? So let this LED pin variable equals to 13, a constant value. I think it's clear, right? I hope it's clear, right? So I need to first thing to define any of the variable for any of the components. You have to just remember one thing. So if you want to define a variable for any of the component you want to interface with the Arduino, you have to make sure it's a constant integer. The variable should be a constant and integer, right? And then you can define it any of the 13 pins. You can write it 2, 4, 5, 6, 7, 13, whatever you want, right? Up to 13. Got it? Got it? Amazing. Thank you for saying that. Yeah. So now, next, amazing. Now, let's talk about some other variables. For example, if we want to integrate a sensor, right? If we want to integrate a sensor, then our sensor will give us the value of 0 to 1023, right? So we have learned in our previous class that all the analog pins as a input, they give 0 to 1023 digital values or digit integer values. So I will set my that variable which will be collecting the sensor data or sensor value into an integer, right? As you can see, it's read 0 to 1023. And this is called initialization, right? So whenever you code with Arduino IDE or C programming, you have to first define the variables, right? So this is the part which you have to do before entering, the other parts. For example, let me just show you, right? So uh, let me show you in the IDE. Yeah, you can see, right? This is the code. This is our, Arduino IDE. So as you can see, we are having two functions, which is void setup and void loop. And the first part which we have to do is I'm writing a comment, right? So this comment will be saying that the first step is to initialize the variables. All right. So this is a comment, and whatever I have written inside this, double black slash, this becomes a comment, and this line will be completely ignored by my IDE. All right. Okay. So I have to initialize first the variables. So what I say, if I want to interface a LED, what I will do, I will first define it as it is a constant, right? So the constant, if we want to write a constant, what we have to write? We have to write it as const, right? So if we are, writing it as a constant, const, constant, and my variable is an integer, right? So it's a constant integer, and let's say my LED, my variable name is LED one, right? So I will click the equals to and I will write it as, let's say, the pin number 9, right? And it will end with a semicolon, right? So this is the first line of code, which means I have defined the variable LED1, which is a constant, right? And it's an integer value 9. Got it? First part done. What is the next? For example, if I'm interfacing one push button, right? So as you already know, what the push button does is the push button, is an analog, it gets the analog signal or ultrasonic sensor. It gets the analog signal as an input, right? And that analog signal is having 0 to 1023 integer values. So what I need to do now, my variable, I have to define a variable, say sensor, right? Right. So now this sensor, I need to change this, the sensor value. This is a variable sensor. So this will be changing continuously, right? Whenever, like for example, if I'm using an ultrasonic sensor, whenever I'm close to it or whenever I'm far away, so the value of this sensor variable will be changing. So I should not use this constant code here. So here I will just write it as int sensor, and I will set the initial value as 0, right? Because let it be set up with 0. Let's start with 0. Let it be changed, right? So as I haven't write this constant, it will be changed, right? Got it? I hope you got it. Right. Now, if we see here, next we are having float, right? So as we have discussed, if we are using a ultrasonic sensor, we have to check the distance, right? Now, distance, for example, the distance between you and your computer screen, is it exactly an integer? No, right? It is exactly 5 centimeter away, 10 centimeter away. No, it may be 5.5 centimeter away. It may be 5.2 centimeter away, right? So it's is a decimal value. And whenever the decimal value comes, you have to define it as float, right? FLO, float. Right. So this is a float data type. And for example, it's a distance, right? Distance. And let it initialize with zero, right? So it will be initialized with zero, but next, once it start getting the data, it will change its value and it will change it to 1.5, 1.3, 1.6, like that. All right. So I hope this part is clear for you, the comment and how to define the variables. All right. Amazing, guys. Amazing. Super. You are going super well. Now, if now let's move on to our PPT. Repeat. Okay. Okay, I'm repeating it once. Let's see the codes, right? And you will be understanding it much better. Okay. Let me just explain it once again. What's happening here is to write any code, we have to first do it in some steps, right? If you want to start with Arduino IE, we want to write the C++ code, we have to see that we are having two functions, right? One is void setup, which will run my code for just once, and we are having void loop, which acts like a forever loop in the picto block. So it will run my code forever, right? But before that, the first part for coding into C++ is we have to define the variables, right? What are the variables we are using? So if we want to interface a LED, right? If you want to interface a LED, we need to define the LED's pin number, right? And for defining that pin number, we need to set a variable, right? So that variable should be a constant value. That's what I have seen. So whenever you are interfacing any of the components, whether a sensor, whether an actuator, whether a LED, you have to always make sure that that is a constant value and that we can write it as const constant, right? And it should be an integer value and let's say LED pin and which is equals to say any of the 13 pin you can use. So I'm using pin number 10, right? Just this is how you can define it, right? With a semicolon ending it, right? Then the next part is you can define any of the variables you want to use in your code. For example, if I want to use a code that will be checking the button state, right? So the button state can be in between the value of 0 to 1023, right? And it is an integer value and it should not be a constant value because I'm changing it in the inside the code, right? So that's why I will not write the constant. I will write it as int and let's say button state and I will initialize it with zero because I will be changing it in this loop, right? So first I have to initialize it with zero. Okay. Then if I want to check or if I want to create a variable which will be changing the value in decimal places. So here I can only change the value by any integer, right? I can't make it 2.5, 2.6, right? But if I require a variable, for example, a ultrasonic sensor, which is getting the data, which says you the distance between you and that object, right? For that case, we require a variable which will be able to collect or to show you the distance in point form also, right? The distance is 25.6 centimeter away, right? So for that reason, we require this data type which called as floating point number or float, right? So then you have to click the float and write the variable name. You can write it anything. For example, ultrasonic, ultra sensor, right? Ultra sensor and you have to initialize with zero. Got it? Got it? So this is about the variables, how to set up the variables and what are the data types, how to write or set the variables. Got it? Should we move on? Amazing. Let's move on. No need to worry if you are not understanding much. If you are looking into this for the first time, it will be a little bit difficult for you. But at the end, we will be doing one program right? You can try it by yourself. Everything gonna be clear. All right? No need to worry about that. Let's move on. Now let's talk about the statements. So there are three important statements or instruction, which is very important to start with your first program in C++ coding. Okay. Now, first statement is pin mode. Right? What is this pin mode? So this pin mode basically sets your variable. Okay, it sets the variable and into the mode, whether it is an input, whether it is an output, right? So for example, if you are interfacing a button, so it will be an input, right? But if you are interfacing one LED, it will be output, right? So here you can see in this code, it's written pin 13 output. Means what? The 13 number pin is set as output. Okay, got it? That's it. That's it. And this will be inside the void setup. So in the void setup, you have to always use the pin mode in order to define which pin will be doing what. All right, got it? Now let's talk about the digital write. Now the digital write, as with the word digital write, you can understand what it does. It basically gives uh, the signal value or the output. If you are using pin number 13 as output pin, then you have to write whether the output is high or low, right? And you can write it using this. For example, I have interfaced one LED with this pin number 13 of my Arduino. Now I want my LED to glow. So what I will do is I will write it as digital write pin number 13, make it high. So my uh, LED will be turning on. Okay, got it, got it. Similarly, if we talk about the third one, that is called digital read. So what is digital write? It's about giving the output. So can you guess what will be about the digital read? It's pretty simple, right? If digital write is about giving you output, then digital read will be taking the input, right? Yes. So now how to read the data, right? As you can see, whenever we were reading using the pictoblocks, we used to define one variable and we are storing all the reading data into that variable, right? And we will be doing the same thing here in IDE. So first we will define one variable and value, right? And then we will be equating it with the digital read and pin number, right? Got it? Got it? Amazing. Amazing. So let's do it. Then it will be more clear, I guess. Uh, so let me just come to the screen. Mm, yeah, here we go. All right, guys. I hope you can see my screen, right, of the Arduino IDE. Now let's remove everything and uh, let's let's say let's check with the pictoblocks first, right? So this is our pictoblocks, right? And what we require to do is we have to first grab this, right? You can see in the pictoblocks also we are having the same code, white setup, white loop. Now, first thing what I will do is I will set digital pin 13 as high, right? So you can see what happening here is I am I haven't used the loop, right? Forever loop. That's why in the void setup, first my pin mode 13 is a output pin. The pin mode is setting up, right? First thing. Second, what is happening? Secondly, my digital write, I'm using the digital write 13 and it says true, right? So means I want my output to be high. Got it? Similarly, if I input it low, it will become false. Right? Got it? Got it? Now, now, what I will do is I will write the same code in a different way, right? So here, let's say, let me just make it side by side. I hope it's oh no, it's looking worst. So it's better. Uh, I will just copy this code. Okay. Yes. So you can see I'm having this code, right? And you can write it true, false, or you can write high, or you can write it low, right? Nothing wrong here, right? But the same code can be written by first defining the variable. So I will define a variable known as LED pin. Okay, and this variable will be a constant value. So I will write it as, you know, constant int LED pin, which is equals to say pin number 30, right? Semicolon. Now, once I have defined this variable as 13, so in the place of this 13, I can write the LED pin. Wherever I have written the 13, I can read the LED pin. So it's up to you how you gonna use it, right? But it's a good practice whenever you are using IDE to first define a variable with the pin number and then write the pin numbers variable and then set up it. Got it? Got it? Okay. So this is the difference between this ID, PictoBlocks codes and this IDE code, right? Got it? Amazing. Now let's say, uh, let me show you here. See, I'm putting this inside the forever loop. Now what's happening? Now what's happening? Now my the spin mode has been set up here. See, always whenever you set a digital pin to 13, it will be inside this void setup, right? And whenever you set that output as high or low, it will be inside the loop, right? So if you want to run this code forever, you have to put it inside this block. Got it? It's that simple. Okay, it's that simple. Similarly, you can see if you grab this block which says wait for 1 second, you will get this function or this statement which called delay. Okay, and what it does is one multiplies by 1,000, right? So you can directly write 1,000. So these are the few things which you have to just it's a simple logic, right? So here, if it's written one multiplies with 1,000, which means you can write it here directly. Delay 1,000, right? 1,000. So what it will do is it will just delay your code for 1 second. So whenever your machine is reading this line and then it's this line, it will wait for 1 second. And then it will again go to this loop line and then again it will run. Right. So this is how the delay works. Right. Now, as we have learned about variables, setups, loops. Let's write our first code and do it, right? Let's do it. Let's do it. Now, what I will do is I will first write a code, the first code which we have used, right? So let me find out my OD. Check that OD here. Sure. Yeah. Okay, fine. So let's write our first code. Let's remove everything. Okay. So let's remove this and this, and also fine. Also see, you don't need to install IDE right now if you're not having a physical Arduino. You can directly work with this WorkV, right? So you can directly work with the WorkV. Okay, let me just show you. Okay, uh, Where is the workpiece part? Because it's here. Yes. Yes. I think you can see, right? So you can directly work with the workpiece where you have to just click here. You have to go to Arduino Uno. You can see the same function is having here also, right? So you can directly work with workpiece. You don't need to require to install this IDE for now, right? So you just have to use the workpiece only. So let's do it in the workpiece, right? Let's do it in the workpiece. What we have to do is first to interface a LED, right? To interface a LED, what we require to do is just remember this words which I'm telling to you. First thing, you have to define a constant variable, which is an integer, right? Const constant variable, which is an integer, and name whatever variable you want to give to your LED, right? This is your LED. So write LED1, let's say, or LED pin, right? LED pin equals to pin number 10. Okay. Semicolon. Got it? Define the variable. Now you require just one variable because I want to interface one LED and I want to make it blink after every 1 second. Okay. So what I will do is next part I have to set up. And what will be my setup? So my setup will be pin mode, where in the pin mode, PIN and MODE is M is capital, bracket open, bracket close. And inside this, I have to write the variable where I am storing the pin number, right? So I will write the pin number as LED pin and I want it as an output, right? I want it as an output, right? And now it's done. Now what is the thing which left? It's about the semicolon. You have to always make sure you are giving the semicolon, right? Now to make it continuously blink forever, I have to write the next code, which is digital write, right? As we have discussed in our PPT, right? If we want to give a signal or an output to the LED or any component, we have to use this function known as a digital write, right? So we have to use the digital write. So what I will do is I will write just digital and capital WRIT, digital write, bracket open, bracket close. Inside, I have to write LED pin, right? Comma, then high, right? So it will make my LED high. Then I will write delay, right? And how much delay I want? For say 1 second. So it will be delay 1000, right? And semicolon. So what it will do? It will turn my LED 1 for 1 second. And then again it will go to the loop and again it will run the same code. But what I want is I want to blink my LED. So what I will do? I will again write digital write and then I will say LED pin, right? LED pin my variable and I will make it low, right? So it will turn off my LED and then again delay of 1 second or 1000, right? Got it? That's it. That's it. So it's very simple to code also. So PictoBlocks is easy, but I will say C++ is much more easy, right? And once you are habituated with it, you will be having the fun to create your own codes. You don't require even ChatGPT to write your codes, right? Although I will show you in the upcoming session in the last week how to use ChatGPT. Okay, that's it. Amazing. So now can you understand the code right now? You are using PictoBlocks previously. Now, can you understand the code, right? You're first defining a constant variable for your LED pin. You have named the variable as LED pin and you made it a constant integer and the value of the integer is 10, right? So we have defined the variable, right? So in the comment, I will write, we have defined our variable, right? So after our variable is created, what we did, we have convert that, we have make the pin mode as output, right? Inside the setup, you have to write pin mode, write the name of the variable as output. Got it? And this is how we have interfaced our LED. And then we want our LED to blink after 1 second. So what is happening here? First, my LED will be glowing and it will be glowing for 1 second. Then after that, our LED will be turning off and it will stay off for 1 second and again it will go to the top of this loop and then again it will turn on my LED. Let's see, is it working that way or not? So I will add the LED, right? And this is my ground pin, will go to the ground and this is my positive pin and I have taken the digital LED pin as 10, right? So I will interface it with the LED pin 10. Now just run it and let's see. Okay. Oh. So sorry. Yes. Okay. So our server is again pretty much high, right? Not an issue. We will be working with our real hardware and let it be compiled, right? So no need to worry about it. Um, we are having our LED. Let's wait. Okay. Let it be running, guys. Mm, I guess. All right, guys. So it's taking a bit of time. I don't know why. Uh, okay. Okay, let's just again cancel it and then run it. Uh, let's again turn on the workflow. Arduino Uno, go to Uno. This is our code. We have to again do the connections. This is my LED. This is my positive pin going to pin number 10. Negative pin going to my ground. Let's run it. Okay. Server load is high. I don't know why it happens always while executing, but definitely it's gonna work. You can try it by yourself if you are in computer. And let me also show you in the real Arduino. So what we will do, we will write the same code here. So as we have already written here, I will just copy it and I will paste it uh, here. Okay, yeah, I think you can see, right? So I will go here in my IDE. I will just paste it, right? Now, here you have to select the boards, right? So here is my Arduino, cute little Arduino. What I will do is I will just connect the USB uh, port to the laptop's USB port. Once it's connected, you can see it will show me this port, COM4 serial port USB port. You have to select it and you have to search the name of your board. So my microcontroller board is Arduino Uno, right? So just click on it and done, right? And once it's done, the first thing you have to check whether you have written the code correctly or not. So just click on this tick mark. It will compile your code and it says done compiling means your code is correct. The next part, what you have to do, you have to just load the code, right? So for that, um, let's us just let me show you cam. Just a second, guys. Let me just show you. Uh, Yeah, in the camera view, then it will be easier for you to understand, right? Just a minute. I know today's session is looking very heavy, but don't worry. Uh, Once you start doing it by yourself, uh, it's gonna be super interesting. All right. Okay, so camera is not turning on. Mm, okay, that's fine. No issue. We will do it without our camera. I guess it's good, right? So yeah. So let me just show you. Okay. I think you can see the Arduino, right? I don't know whether you can see or not. Yeah. You can see the Arduino, right? So this is my Arduino. Okay. Yeah. I know it's pretty bad view, but not an issue. We are having our LED, right? So we have written our codes. Let me just minimize it. Yeah. We have written our code. This is our code. This is our Arduino. And we have set up the pin number 10, right? So we will just take the breadboard, connect our LED with it. All right. This is our LED, right? We will connect it with the breadboard, right? And then what we have to do is we have to put the ground pin with the ground, right? This is our ground. And then we have to put the positive pin with the positive terminal and to the digital pin 10. So it is 8, 9, 10. Okay. Right. All right. Oh, I think you can't see it. So this is. So you can see this is my LED. I have interfaced it such that the ground is going to the ground of the Arduino board and the positive pin is going to the positive terminal of the LED. Now what I have to do is I have to just upload the code using this arrow mark, right? So if I click on this, it will start uploading and done uploading. Whoa, you can see. Can you see? My LED is blinking. It's turning on for 1 second, turning off for 1 second. Boom. So it's working, right? So this is how you can work directly with ideally, right? With the hardwares. And if you want to simulate it, then you can go to the simulation and you can see here it's our simulation is also working the same way, right? All right. Amazing. So this is how we are at the end of our session because I feel like it's been too, it's been a too hectic session for you all. Uh, but it's fine. Um, yeah, right. All right. So we have completed our, you know, first programming with IDE with direct C++ coding language. So guys, can you look at yourself how much you have improved? You started with just code blocks with picto blocks. No, that's interesting. Yeah. Yeah. So it's interesting, right? You have started by just, grabbing the blocks, building the blocks, and you're coding. You first blink your LED. And now, right now, you are capable of writing the actual C++ code using this functions, this small statements, right? So there are a few all statements like if, else statements. We will talk about it in the next session. So stay tuned and love you guys. All right. So we will talk about ifs and else statement, and uh, also, we will be knowing how to interface a push button in a different way, in a much easier way, uh, not like using the resistance, power supply, and those things, right? It will be very simple to use. It's just like interfacing on LED with, right? So we will be knowing how that gonna be working. We will be also integrating the push button with the LED, just the same code, but in IDE directly, writing the C++ code rather using the pictoblocks. Okay. So thank you so much, guys. That's all for today's. Thank you so much for staying with the session, and love you all. That's amazing. And see you in the next session. Stay tuned for upcoming sessions. And for today's session, there will be assessment for just last session and today's session. Together we will be having the assessment. So all the 10 questions will be based on that those two sessions. And amazing, guys. And if you are having any kind of doubt, any kind of questions regarding this session, you can write it in the comment section. Also, after the session ends, you can write a beautiful comments so that people can see how you know a session is going on. Great. So great, guys. See you again in the next session. For today, bye bye. And also, uh, you can try this activities by your own, right? Whatever we have did in our today's sessions, like interfacing the LED, writing your first code, okay? And then in the next session, we'll be talking with how to interface sensors using direct Arduino codes, right? And we'll be also talking about the ultrasonic sensor. Okay, bye guys. Stay tuned.